Okay, so we're going to be going through these revision questions, and the first few questions you will get are mostly questions that you would have learned from primary or prep school or in grade 7. Okay, for example, we have a few fraction questions, but we're still going to go through these. Okay, so we have 2/3 plus 4/6 times 1/2. Remember, order of operation says that when you have more than one operation in the same expression, you are going to do it in the BODMAS or PEMDAS order. So that's parentheses, which is another name for brackets, exponents, which is another term for powers, multiplication or division, then addition or subtraction. Okay, so we're going to be doing the multiplication part of this expression before we add. So that means we're going to zone in on this part of the expression, which is 4/6 times 1/2. Okay, so how do we multiply fractions? Multiplying fractions is very straightforward. To multiply your fractions, all you have to do is multiply the numerators and multiply the denominators. So the product of the numerators will become the numerator for your answer, and the product of the denominators will become the denominator of your answer. Okay, so we're going to say 4 times 1 is 4, and 6 times 2 is 12. Okay, now that we're finished with the multiplication part, so we got 4/12, we're going to end up with 2/3 plus 4/12. Okay, so how do we add fractions? Especially unlike fractions. So unlike fractions are fractions with different denominators. So how do we add two numbers, or two fractions rather, with different denominators? Now, if they were like fractions, you could just add up the numerators and keep the same denominators the two fractions have. But when you're adding unlike fractions, the best thing to do is to find a common denominator. So this way, you are going to write these two fractions as like fractions. Okay, so how do we get these two fractions to become like fractions? I would suggest that you find the LCM between the denominators of your fractions. Okay, so what's the lowest common multiple of 3 and 12? That would be 12. Okay, once you're finished doing that, you're going to divide each denominator into your LCM, or we call it LCD, lowest common denominator. And the lowest common multiple, just a recap, is the smallest multiple for a set of numbers. Okay, so the smallest multiple for 3 and 12 would be 12. Okay, so we're going to divide each denominator into our LCD, which is 12. Okay, so 3 into 12 is going to be 4 times. Now, what are you going to do with that 4? You're going to multiply it by the numerator. Okay, so we get 2 times 4, that's going to give us 8. So we're going to write 8 in the numerator. Next, we're going to divide the other denominator. So 12 into 12 would be 1 time. And again, we're going to multiply that times the numerator for this fraction, and that's going to give you 4. Okay, so we have two like fractions now. Even though I have it written 1 time, really and truly, we're adding 8/12 plus 4/12. Okay, our final answer is going to be, so since we have two like fractions and we're adding, we're just going to add up the numerators, and that is going to give you 12/12. We can break this down and say 12 into itself is 1 time, so we can write this as 1. Okay, I'm going to have to snip this question here to the next slide. Okay, so we have again more than one operation in the same expression. Now the best thing to do is to work out the numerator or the operation in the numerator and work out the operation in the denominator separately. Okay, so let us work out 4/7 divided by 2/49. Okay, so what do we do when we are dividing fractions? Now we are going to use the keep, change, and flip rule. Keep, change, flip. This means that you're going to keep the first fraction the same, you're going to change the division to multiplication, and you're going to flip the second fraction. Okay, so this is what we are going to write. So we keep the first fraction the same. We're going to change that division to multiplication, and we're going to flip this fraction. Okay, now we're multiplying two fractions, and we know how to multiply two fractions. So we're just going to multiply the numerators and the denominators. Okay, so 49 times 4 is giving me 196 and 7 times 2 would be 14. Okay, let me see if I can break this down. Okay, so 14 is divisible. Sorry, 196 is divisible by 14, and you would get 14. Okay, so you can break this down to say 14 as our final answer for the numerator. Okay, now that we've worked out the numerator, we're going to go ahead and work out our denominator, the operation in the denominator. Okay, to do that, we are just multiplying two fractions, so we already know what to do. Multiply the numerators, and we would get 2/6. So the original question had asked us to divide what is in the numerator. So we got 14, and what is in the denominator, we got 2/6. Okay, so we're going to end up with 14 over. So remember, what we got in the denominator was 2/6, so it's going to be 2/6. Okay, a better way to write this is with the division sign to make things a little clearer. Okay, and we know what to do when we're dividing fractions, so we're going to use keep, change, and flip again. Alright, how can we get 14 to be a fraction so we can end up dividing fractions? When you want a whole number to be a fraction, you're just going to write it over 1. Okay, so we're going to end up with 14 divided by 2/6. Then we're going to use the keep, change, flip rule. So we keep the first fraction the same. We're going to change that sign to multiplication. And we're going to flip this fraction. And this is going to give us 14 times 6 is going to give you, I got 84, and in the denominator 1 times 2 we would get 2. Okay, 2 is divisible by 84 is divisible by 2, right? Okay, so since 84 is divisible by 2, we can break this down into, okay, 2 into 8 is 4 times, and 2 into 4 would be 2 times. So our final answer could be, so 8 over 4 is still correct, but we can break that down into 42. Okay, just double checking my answer. Good. Alright, so that's it for this question. Let's do number 2. It says, using a calculator or otherwise, find the value of 55.62 times 2.31 minus 3.65. Okay, if you were to do this without the calculator, it's fairly simple. You're just going to take out the decimal point. Sorry for this stuttering. You're going to take out the decimal point from these numbers that you're about to multiply. And remember, the order of operation rule still applies. So we're going to multiply before we subtract. Okay, so before multiplying these two decimal numbers, you're going to remove the decimal point from these two numbers, and you're going to multiply them as if they're whole numbers. Once you're finished with that, you're going to find out where the decimal point should go in your answer. Okay, I'm going to tell you what you would get if you were to do it without your calculator. Okay, so let us say that we multiplied these two numbers as if they were whole numbers. You would get okay, I'm writing what you would get if you were to multiply these without your calculator. Alright, this is a very big number. Okay, so this is what you would get. Now, to find out where your decimal point should go, you're going to count the total number of decimal places in the numbers that you multiply. So we have a total of 4 decimal places, or 4 digits behind the decimal point in the two numbers that we multiplied. So it's the total number of decimal places that you're going to use. Okay, so since this is a whole number, we're going to find out where the decimal point should go. So it's 4 times, and the decimal point would end up here. So for this part of it, it's going to be 208.4822. And since you're allowed to use your calculator for this part, you can use your calculator to double check this answer. Okay, for the subtraction part, you're going to subtract 3.65 from this number. So when you're doing that part without your calculator, you have to ensure that your decimal points line up and you put each digit in the correct place value. So you're going to line up the place value, in other words. Okay, so you'll notice that all of the digits in the tens place are lined up. Sorry, this is the tens place. All the digits in the hundreds place are lined up. All the digits in the tens place are lined up. And all of the digits in the ones place are also lined up. So it's like you're writing them in columns. Okay, once you've done that, you're going to go ahead and add. So there's nothing to add to these digits, so we're just going to write them. Then we have 8 and 5 is 13. Carry 1. Okay, 1 plus 4 is 5. 5 plus 6 is 11. Now remember, the decimal point should be here. So we have to ensure that the decimal point is in the same place in our answer. So the decimal points must always line up. Okay, so we're going to carry 1 again. 1 plus 8 is 9. 9 plus 3 is 12. Carry 1 again, and we get 3. There's no number to add to this number, so we're just going to write it here. Okay, so our final answer is going to be 132.1322. Okay, it says give your answer exactly to 2 decimal places. Okay, so 2 decimal places means that there should only be 2 digits behind the decimal point. Okay, so how do we round? You're going to start by identifying the digits in the place value that you're rounding to, or the number of place values you're rounding to. Okay, we're asked to round to 2 decimal places, so I'm going to just circle the number in the second decimal place. Once you're finished with that, you're going to look at the digit behind it. So the digit behind it is 2. The digit behind it will tell you whether or not you round up or down. Alright, so round up means that if the digit behind it is 5 or more, you're going to add 1 to the second place value. If it is less than 5, you're going to round down. That means you're going to leave the digit in the second place value as is, and you just remove all of the numbers that come after the second decimal place. Okay, we also need to keep in mind the difference between rounding whole numbers and decimal numbers is that when you're rounding whole numbers, you would add zeros, or you would replace all of the digits that you dropped off or removed with zeros. But when you're rounding decimals, you don't do that. So all of the digits that we're going to remove, we're not going to replace them with zeros. We only do that when we're rounding whole numbers. Okay, so let's go ahead and round. Alright, so the digit behind it is less than 5, so we're going to round down. That means we're going to just remove everything that comes after the second decimal place. And our final answer is going to be 132.13, and that's it. Alright, 3 significant figures. Now, there are rules for significant figures. To be sure, I would suggest that you go back to your notes. Now, 0 can be a significant figure. So keep in mind, it is not only just non-zero digits that are significant. So you'll have to look at the rules for trailing zeros and leading zeros. Alright, so in this number we have a total of 7 significant figures. Why? Because all non-zero digits are significant. Okay, so non-zero means that it is not 0. So none of these digits here are 0. So all of them are non-zero digits. And all non-zero digits are significant. Now it's asking us to round to 3 significant figures. That means when we round, we should only have 3 significant figures left. What I'm going to do, I'm going to start by identifying the third significant figure. So it's similar to when you're rounding normally. So you're going to start by identifying the number or the digits that is the third significant figure, which would be this 2. Then you're going to look behind it to see whether or not you round up or down. Okay, so we have 1 behind it, and since we have a number or digit that is less than 5, that means we're going to round down. And to round down means that you're going to just remove all of the digits behind the third significant figure, and you're going to leave it as is. So you're not going to add 1. So our final answer is going to be 132. Okay, question C says we're supposed to write this in standard form. Standard form, the basic rules is that you're going to write your number as a number between, or you're going to move the decimal point rather, sorry. You're going to move the decimal point until you have a number that is 1 or more but less than 10. Okay, so how do we do that for this number? Alright, I'm going to rewrite this number.